Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marylou.
And in studio with us we have Angel. And Angel, if somebody needed to contact us, what would they need to do?
For math homework, help and call in Bakersfield 636-4357, and anywhere else is 1-866-636-6284. Email is dothemath@current.org. We are online at dothemathonline.net, and social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So, where do you go to school and what grade are you in?
I go to Fairview Elementary, and I'm in 5th grade.
How is 5th grade?
Fun.
It's fun? What do you like about 5th grade?
There's mostly more fun things I don't know about.
So you're learning a lot of things, okay? So what kinds of things have you done in math so far this year that are new to you?
Multiplying and dividing mixed fractions and numbers.
Okay, so that's kind of what you're doing right now. You brought in some homework and it looks like you've got some mixed numbers that you're adding and subtracting right now, right?
Yeah.
How's that going?
I'll get kind of confused on some questions.
Well, it's a good thing you're here today then, right?
Yeah.
Okay, well, you know what? Before we get to all of that, we're going to take a look at the problem of the day. Did you know that Do the Math has a problem of the day?
No.
Well, now you do. We're going to take a look at it together because it's on all of the social media stuff, I think. And just like you said, it's Facebook, Instagram, Twitter, and YouTube. And the problem of the day is on the social media. So here it is. It says 862 divided by 4. Now, we're going to talk about this and we're going to just mental math kind of do this.
Okay.
So what would you do first with that problem? 862 divided by 4.
First, I'll look at the first number, which is 8, and see how many times 4 could go into 8, which is 2.
Okay, so let's take a look at the options. We have 211, 858, 215.5, and 21.5. We know that the first number is going to be 2.
Yeah.
So can we get rid of any of those answers yet?
No. Wait. Yeah, no, because 4, you could get 4 by 6 by 1.
Okay, so far we have 2 and a 1.
But then the 2, you can't do that.
Okay, so we'll bring that down.
Yeah.
And then we'll bring the other 2 down. Mm-hmm. So now it's 4 into 22.
You could go in that by 5 times.
Okay, so now we have 215, but now we have to add a 0 because we have a 2 left over.
Yeah.
So if we add a 0 and a decimal,
it's a 0.5.
So, right, there you go. So which one of those options is correct?
D.
So, okay, so you might not be able to see it. So C says 215.5 and D is 21.5.
Oh.
So it looks kind of, from where we're standing, it kind of looks the same almost, right?
Yeah.
So you're going to go with C, 215.5?
No, I meant to say D.
Which one?
D.
Let's talk about this again. 4 goes into 8 how many times?
Oh, wait, yeah, C.
Well, hold on now, brother. You go in D now. C, now which one are you going to do? All right, can we get rid of B?
Yes.
Why?
Because it's wrong, because 4 can go into 8.
That doesn't even make sense, does
Yeah.
it? That's just taking 4 away from 862.
Yeah.
So B's gone. Can A be gone?
Yes.
All right, we don't even have a 5 or a decimal in there, and we know we need a decimal and a 5 at the end, right?
Yes.
All right, now you're down to 2. Now, This is going to be a long hour, but it's going to go by fast if we get this problem out of the way. So
Okay.
you want to go with C or D?
C.
Are you sure?
Yes.
You're positive? Why?
Because the C has the main answer.
Okay. Because when we said it, we said 215, and then we need a decimal point in the 5.
Yeah.
So I think because we weren't writing it and we were doing it mentally, that kind of throws things off a little sometimes,
Yeah.
right?
But another
Okay.
way, Angel, that you could check yourself, if we look at the choice for D, which was 21 and 5/10,
Right.
correct? Let's think about this. What's 4 times 20?
4 times 20 is 5.
No, 4 times 20
Oh, 4 times 20 is 80.
is 80. So we know our question, right? What the number we were dividing, 862, that's a lot bigger than just 80, huh?
Yeah.
So just looking at that, knowing that, well, 4 times 20 is 80, well, that number's a lot larger than that, so it doesn't make sense, does it?
Yeah, it does not make sense.
Yeah.
Yeah, and you actually had it right because you said 215.5, and then you looked at it, it was like D, and then you were giving me all sorts of curveballs there, son, all right? All right, so we're solid on C.
Yeah.
All right, well, let's take a look and see if that is correct. Oh, there it is. C is correct. Nicely done, dude. First one done. This isn't so bad, is it?
Yeah.
All right. Hey, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Before we get to Angel's homework problems, let's first take a look at today's Math in the News. All right, so Angel, have you been at Fairview School for a long time?
Since kindergarten.
Since kindergarten, so it's fair to say that you've grown up in Bakersfield?
Yeah.
Okay. Have you ever had an opportunity to go and be in the snow?
No, I've never been in the snow.
You've never been in the snow. You think you would like to be in the snow sometime? Like
yeah.
just go play and check it out for a little while?
Yeah.
All right. What do you think it would be like?
Definitely cold
Okay, definitely cold, right?
and just fun.
Yeah, it would be fun, right? I mean, your first time in snow, it's a lot of fun, right? It's a little cold, but I mean, you're young. It's not even going to really be cold.
Yeah.
Okay, a lot of people think it's freezing out and stuff like that, but it's not freezing all the time, right? You just have to have the right conditions and you get some snow. So hopefully soon you have an opportunity to go check out the snow. Do you think you would make a snowman if you were in the snow?
Definitely.
Yeah, that's one thing you got to do, right? And then lay down, make snow angels and stuff like that, right?
Yeah.
So snowfall and snow depth, that's what we're going to talk about today.
Okay.
You think you have any idea what either of those terms mean? I mean, I know you don't grow up in the snow, you've never been in it,
I think snowfall is when like the snow goes down on the ground, but I don't know what snow depth means.
well, that's what we're going to take a look at today, all right? So here's a couple of years ago, but this is where they get a lot of snow, okay? And we can see that the estimated storm total snowfall, so this is how much is going to fall onto the ground
Okay.
in a certain period, all right? Do you know what these little marks mean, these double, they look like they would be quotation marks, but they also stand for other things. Do you know what those stand for in math?
Wait. Aren't
So this
those-
says 4 to 6. Do you think it's 4 to 6? They're
Four.
talking about the amount of snow that would fall on the ground.
It'll be around 4 to 6.
So inches, feet, miles, what do you think?
I think it might be. I never saw these before.
Okay, well, these are for inches.
Oh.
So if you see 2 of those are inches, and if you see just 1, it's feet.
Whoa.
All right? So here we can see that this area in the yellow is going to get the most snow projected, right? 6 to 8 inches. Now, the 6 to 8 inches, right?
Yeah.
There's 8 inches right there. That would be that much snow on the ground.
Oh, that's a lot.
That is a lot, right? That'd be up over your shoes and stuff, right? So it
Yes.
get kind of messy after a little bit. But anyway, let's take a look, and here's snow depth. Okay, so this is the depth of the snow, not just what has recently fallen on the ground. So let's say you wake up one day, there's snow starting to fall. And then the amount of snow that falls, if it continues snowing all day and all night, and when you wake up the next day, that 24-hour time period, that would be the snowfall.
Uh-huh.
Make sense? Okay. And if it stopped at some point, that's fine. But here we can see measuring snow. So snowfall is using a flat surface multiple times during a 24-hour period. All right, so we can see that Monday at 7 o'clock is when you wake up.
Yes.
Okay, you go to school, 9 o'clock it starts to begin to snow. All right?
Oh.
It keeps on snowing. We've got 2.4 inches. Snow begins again because it stopped for a little while, right?
Okay.
Then by the time you wake up the next morning, because more has accumulated,
Okay.
all right? So now you've got 3.4 inches. That is snowfall. Snow depth is everything that is combined.
So,
So it's not just the new stuff, it's the stuff that may have been there and the new stuff on top of it.
oh, so like old snow on top of the new snow?
Right. Okay, so you've got old snow, right? So let's say you wake up one day and there's a couple of inches of snow, right? And it stops snowing, right, for a day. Okay, and then you go to school the next day, it starts snowing, and then you wake up the next day, and now it's 7. So the first day you had 3 inches of snowfall.
Yeah.
The next time you had 4 inches of snowfall, but your snow depth is now 7 inches altogether.
Oh, okay. So the old snow combines with the new snow and to make it larger.
There you go. So that is the snow depth, all right? And then we can see, because when snow melts, it turns into water,
Yeah.
all right? Have you noticed all of the rain we had kind of recently?
Yeah.
Did you like that, all that rain?
Yes, I run around.
You run around in the rain? Yeah, you know what? That's what you ought to do, right? You kid. It doesn't rain in Bakersfield that often, right? So if you get an opportunity, go outside, run around and stuff like that. Do they let you do that at school, or do they keep you inside?
When it's like a rainy day schedule, sometimes when we switch, I kind of stay in the rain while we're walking to the next class.
Yeah, rainy day schedule, right? Because you have to switch classes and stuff,
Yeah.
but you go out in the rain anyway, right? And there you go. Right? You don't get that many opportunities, right?
I'm with him on that.
It's just funny though when the kids see puddles and they purposely go in and jump and like keep going in it, and it's like, all right, it's kind of fun, but after a while it's like your feet are going to be soaked for the rest of the day now, and who knows how comfortable that's going to be. But now we can see, so do you think snow is very heavy?
Maybe not that much.
It could, because there's different types of snow. There's very fluffy snow, and it doesn't really pack together like you would make a snowball or a snowman. You want wet snow for that, so that it all stays together a little more. But we can see that most roofs on houses that are built where it snows all the time can withstand 20 pounds per square foot.
Oh.
And we can see if they have fluffy snow, it's only about 4 pounds per square foot. So it's pretty light. Normal snow, they're saying, right, where you could pack it pretty good and most kids go out and have fun in it and it doesn't just blow around a lot, okay? That's about 6 pounds per square foot. But when you get the heavy stuff, this is when you have to start worrying about how well your roof is, okay? Then you start getting up around 12 and a half, a little bit more, and they depict this by putting vehicles up there, right, to depict kind of what the weight would be like with the amount of snow up there. So you can see how much snow, if you had a foot of snow, the type of snow makes a big difference,
Oh.
okay? So hopefully when you have an opportunity to go see snow, maybe you start off with normal snow.
Okay.
Sound good?
Yes.
All right. That is today's Math in the News. 636-4357 is that phone number. We do have phone tutors available until 5:30 this afternoon. Angel is a 5th grade student from Fairview Elementary. And you said you are working with mixed numbers, correct?
Yeah.
All right. So what we're going to do is we're going to put one of these up here right now. And Mary Lou is going to help you with this. And it looks like you left off in column C.
There you go.
And
Yeah,
let's
Joy.
get that in focus. And here's what we're going to do. We're going to do the first one you have on column C, and just to make sure it's correct.
Okay.
All right, so Mary Lou's going to write it up on the board. We have 4 2/7 plus 3 3/4. And what Angel has is 8 1/28. So maybe put that off to the side someplace.
8 and
1/28, 1 over 28.
1/28. Okay, so that's the answer you have, right?
Yeah.
So Angel, can you kind of walk me through how you solved this problem? What's the first step that you did? And you could go ahead
First,
and
I
write it.
checked if these are common denominators, and if they're same but they're not, so I wrote them down and brought 7 to. I did the multiplication by 7 by 1 is 7. 7 times 2 is 14, and then I do the 7 times 3 is 21, and then I do 7 times 4, which is 28. Then I stop, and I go to 4, which is 4 times 1 equals 4. 4 times 2 equals 8. And 4 times 3 equals 12. I see if you're still the same, but I still need to go more. So that'd be 2 times 4 is 16. 2 times 5 is 20.
4, you mean 4 times 5.
Oh yeah. And then the 6 times 5 is 24. And I look again, and I see that none of them are still the same, so I go one more time.
So
I have 24 times 7, which is 28.
you mean 4 times 7.
Yeah. And so I got two same things, 28 and 28. So
Okay.
I looked at 4, that would be 7 on top, bottom, and 7 on the top. You know, right here is be 28 in the bottom.
Okay.
Up here would be 21.
So you're multiplying these numbers.
Yeah.
You're saying 4 multiplied by 7. So 4 groups of 7 is 28, and 3 groups of 7 is 21. Okay.
And then on top of here, we do 4, which is 4 on the top and then 4 on the bottom. And then you go make another square. 7 times 4 is 28, and 2 times 4 is 8. So I added these and I got 29. I do these last,
Okay.
and this one actually helps me do the last one because it's over the limit of the fraction.
Okay. So you're saying that your numerator is larger than your denominator.
Yes. And
Okay.
so I simplify and see how many times, which that means it will go into 28 through 1. That means there will be one whole, and 4 plus 3 equals 7, plus another whole is 8.
Okay. So you're saying, because this kind of breaks out, if we kind of decompose this a little bit, you have 28 over 28, which is your 1,
Yeah.
plus your 1 over 28, which gets us to be 29 over 28,
Yeah.
right?
Yeah.
So this is your 1 whole, and then you have your 1 28ths, and you're taking this 1 and adding it to the 7 over here.
Yeah.
Okay, to get your 8 and 1/28. Wow, look at all that math. Nicely done.
Yeah, that was well done. And I was just sitting over here just listening to him, and he was on a roll and explained everything beautifully.
Yes, he
Some
did.
great vocabulary. And the way you explained it probably helped some other students that might be having
Yeah.
a little difficulty with it. And doing your multiples right down at the bottom
It was awesome.
is a nice way to show that also. So you feel pretty comfortable with this?
Yeah.
All right. Now you have to do all of these for homework, correct?
Yeah.
You want to do one now that you haven't done?
Okay.
Because we
Okay.
checked that one just to make sure that you were all right
We're
on the
going
right
to go
track.
ahead and erase all
All
that
right, so
beautiful
now let's take a
work.
look at the next one. So we have 7 3/8 plus 3 1/3.
All right, Angel, walk me through just like you did last time.
So first I see if these two are the same. So I put the numbers down here, the bottom numbers, and then I see 8 times 1 is 8. 8 times 2 is 16. And then I do 8 times 3 equals 21. So I stop and go to 3.
I'm going to stop you for a second. Let's think about this one more time. 8 times 3.
20. Oh no, it's 24.
Okay, there you
I was
go.
thinking of the sevens.
Yeah.
And then 3 times 1 is 3.
So I'm going to pause you for a moment there, young man, because I know you're probably looking at this the same way, Mary Lou. Instead, because soon you're going to get numbers where you're going to have to go a long way.
Yes.
Yeah.
So instead of writing them all out, think, can 3 go into 8
Yes.
evenly?
Yeah.
Okay, what was 8 times 3?
8 times 3 is 24.
So can we use that automatically without having to write out all of your numbers?
Yeah.
Okay, so let's go ahead and use this as our denominator,
Okay.
okay?
So that means this would be 3 on 3. No, I mean, this would be 8. This would be 8. 8 on the top and then 8 on the bottom. And then it would be 1 times 8, which is 8. And then 3 times 8 is 24.
Okay.
And on top of here is 3 on the top and then 3 on the bottom. 3 times 9 equals, 3 times 3 equals 9. 8 times 3 equals 24. So now we need to do the addition, which
Okay.
is 17. I finally figured that out in 4th grade when I realized 9 plus 7 is 16. You just add 1 more.
I like your thinking.
And then we do 7 plus 3, which is 10.
And this one, we can't simplify anymore like we did last time, can
Yeah.
we? Why?
Because it's not full.
Oh, it's not full. You mean that our numerator
Is lower.
is smaller than the denominator. And so there we have it, our solution of 10 and 17 over 24. I love the way you told me how you figured out 9 plus 8. Because you said you knew 9 plus,
9 plus 7.
you knew 9 plus 7, and then you added 1 more.
Yeah.
I love that. There you go. Now, again, being more efficient with your thinking, instead of having to write these all out, because you are going to get numbers that are really large, the first thing you want to do is ask yourself, can the smaller denominator, can 3 go into 8 evenly?
Yes.
Can it? Evenly. Is there a number that I can multiply by 3 to equal 8?
No.
No, it can't. However, if that can't, then can we say 8 times 3?
Yes.
Yes, and we get
24.
So that's another way, without having to write out all of your numbers, that's another way to think about that. Do we have time for one more?
Oh, we're going to do one more because I wanted to make sure. Do you have to subtract also?
Oh, yes.
So all of these problems you have to do, correct?
First, that side is first addition. I took the other side, which is subtraction.
So we're going to do a subtraction problem right now.
Okay.
Here we go. So we have 5/8 minus 1/4.
So think about what we just talked about, okay? Ask yourself, what's the smaller denominator?
4.
Okay.
It could fit equally because they're both even numbers.
Okay,
And 4 times 8 is 32.
but 4 does go into 8, right?
Yes, 2 times.
2 times, so can my denominator just be 8?
Yeah. Oh, yeah, it can.
It can, okay, prove it to me.
That would be 2 times. And sometimes when I do multiplication, sometimes I think it's addition, and I do 1 plus 2.
I like it.
But then, so it's 1 times 2 equals 2, and 4 times 2 equals 8. And here is going to be a 1 over 1, and it'll be 5 times 1 equals 5. And then be 8 times 1, which is 8. And then I start doing the multiplication, and now I'm in the subtraction.
Okay.
And I see 2 and 5, so that would be 3. And that's 3 over 8, and you can't simplify.
Okay, so 3 over 8. So again, so what do you think about that? About thinking about if these numbers can go into each other versus the other step of writing everything out.
Yeah.
Yeah?
That one is way more easier.
Okay. All right.
Nicely done. So we will go back and do some more of those, but I wanted to make sure that we got at least one subtraction problem in there right now. For doing some great problems so far today, Angel, you got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations on that. Have you ever been to Chick-fil-A?
Yes.
I have myself
When I
also.
went-
Do you have a favorite thing that you like there?
The burger without the pickles.
Oh, so you don't like the pickles?
Yeah.
That's all right. You know what? That burger is good by itself too, isn't it?
The pickles are too sour.
Oh, all right. Well, you know, different taste for everybody, right? That's what makes it a little different. Well, congratulations on that. We do have phone tutors available until 5:30, and we'll be back with more right after this.
Learning the secrets of the birds and the bees and the wasps can be a hazardous pursuit.
Did you get stung that day when we were on campus?
I sure did.
Thing hit me in the ankle. That's right, your leg swelled up like a melon.
Right.
Georgia Institute of Technology biology professor Michael Goodisman and his team are willing to take it on the ankle and wherever else these aggressive yellow jackets may sting.
All right, it's time to zip in, I guess.
To find out what goes on in the queen's boudoir, if you will.
All right, very good. Let's put the gloves on just to finish off the complete outfit.
And also make walking through this backyard a little less perilous.
They make me abandon any place they are with a 10-foot radius because they are indeed the nastiest, most aggressive insects I've encountered.
He's talking about yellow jackets, wasps with an attitude, and perhaps not coincidentally, the Georgia Tech mascot.
They build nests in bad places, underneath plants or near houses, and so they are a pest. We're gonna go dig them out of the ground while they're still alive. So pour a little bit of ether, just a little bit down their entrance hole. That will hopefully anesthetize them. Okay, here they come. Ren, I can't get in there. Can you pour some ether in there?
Yeah.
They are agitated, no doubt about it. Ooh, she's a big one. Wow, she's big. Not a lot of workers though, very interesting.
Yellow jackets may seem eager to inflict pain, but they have some important redeeming qualities. They kill harmful garden pests and are among the most social insects on the planet, like their stinging cousins, the fire ants and honeybees.
They are very much like honeybees in that they have a single queen that heads the colony. There's the queen, this larger individual surrounded by all her daughter offspring, the workers. They're all just hanging out. They'll come to in just a minute though, that's for sure.
But apparently yellow jacket queens are players. DNA testing reveals they have multiple sex partners, so instead of sister workers, half-sisters guard the nest and feed the queen. Goodisman is using National Science Foundation support to try and understand these complex relationships and how they impact these intricate communities.
There's a big question out there in general about why females of any animal species would mate with multiple males.
Goodisman is not just focused on sex. He's also curious about how social insects within a community work as a team.
They have the highest level of sociality. A queen cannot effectively live without a worker, and a worker without a queen.
He also studies another aggressive backyard pest, fire ants. At this Georgia Tech physics lab, photographs and x-rays capture fire ants at work, digging elaborate underground tunnels. For these ants, caring for their brood and keeping their queen safe are more important than their own lives. This floating blob of fire ants demonstrates their allegiance.
So fire ants do form these living rafts of ants when they get flooded. They basically float on their young, and they'll cannibalize each other to some extent if they have to until they hit land. But the colony survives. That's what it's all about. The colony survives, the queens survive. That is a queen. So you can see she's very different from the workers, much larger than the workers. The male has wings. You see that one right there? It's got a little tiny head and big shoulders, which is kind of a running joke. So they're basically all muscle and very little brain. They don't have much that they do except fly off and mate. And so we study social insects to understand social behavior.
He also understands a lot by studying wasps' nests. He hopes to learn what factors determine whether an egg becomes a worker or a queen.
Queens are much larger. They're built differently. Their physiology is different. They're really two completely different animals. What we have here is actual comb. You can see the cells here are pretty small, and that's because this comb is used exclusively to rear workers and males, both of which are relatively small.
The queen's quarters, or comb, have much bigger cells, and Goodisman believes that may make the difference.
The queen comb is right here. This comb was produced exclusively to rear new queens, which are larger than the workers and the males. All right, let's get this sucker out of the ground, and oh, she's a big one.
Meanwhile, in that yellow jacket-plagued backyard,
All right, we're good.
the hunt is a success. The homeowner has reclaimed his garden, and researchers leave with 3 nests, and this time, nary a sting.
All right, nicely done. Victory over the yellow jackets.
Careful how loud you say that on this campus. For Science Nation, I'm Miles O'Brien.
Well, that was probably the only campus they should have probably gone to when talking about the Yellow Jackets was Georgia Tech. So nicely done with that right there. Speaking of science, it's time now for a little bit from Science for Kern. And in studio with us today, we have Justin from Science for Kern. How are you today?
Oh, I'm doing well. How about yourself?
I'm excellent. So what is your role with the office, and how long have you been with Science for Kern?
I am a STEAM program specialist, and I just started in September. So I was able to move over, and it's like it was planned, but here with Angel, I was a teacher, 5th grade teacher and curriculum specialist in the Greenfield Union School District. And where do you go to school at?
Fairview.
Fairview, and what district is that in?
Oh, I think
Greenfield.
Oh, there you go.
So we're old friends here. We know what to do, and we're going to do a little bit of science together. Okay, you ready for some science?
Yes.
Okay, we're going to mix some chemicals. Have you ever mixed chemicals before?
No.
Do you have the number to the firefighter station?
No.
Okay, well, that may be a problem, but hopefully not. Here we go. Okay, we're going to do something with chemical reactions. Now, the thing with chemical reactions, not every time we mix together chemicals, we get an actual chemical reaction, okay?
Yeah.
There's some things that let us know, okay, this may have been a chemical reaction, and you're going to let me know what you think, all right?
Okay.
So here's what we're going to do. We have some items here. Okay,
Yeah.
you see the thing, the red?
Yeah.
That's called phenol red. Okay, I'm
Phenol
not
red?
going to tell you what it is yet.
Okay.
Okay, I don't want to let you know yet. Then we have calcium chloride.
Yeah.
Have you ever heard of that?
No, but I think I might have seen it before.
Okay, we'll see what it does. And then we have sodium bicarbonate. And I'm going to let you know what that is in a little bit as well. And you're going to say, oh, I've heard of that all the time. Okay? Here's what you're going to do. You're going to take a half teaspoon, the one with the half. You're just doing fractions, so you're a pro at this now. Dip it in the calcium chloride.
Like there.
And you're going to put it in the Ziploc bag. Now you're going to take the quarter teaspoon, the other one, and you're going to dip it in the sodium bicarbonate. We like to use fancy words. That's a nice heaping teaspoon. Yeah, you'll be good with the sugar. And our cookies, perfect. Okay, now before we activate our experiment, we're going to have a model here. Scientists love to model. Okay? Did you ever know that?
I never knew that.
They love to model. When you see all the people walking down the runways, you know, that's scientists.
Oh.
They're modeling. No, I'm just kidding. Those are fashion models. Our models are drawings. We're going to show what happens from before to after, okay? Here's what we're going to do. With some steady hands, take your phenol red, place it gently in it without it spilling yet.
So gently in.
Yes, gently in. Okay, perfect. Now you're going to zip the bag shut.
Zip it.
Very nice. Now, go ahead and lift it up, tip it over, let it all mix up. And you start telling me what you're seeing, what's going on.
Some of them are turning yellow.
Okay, you're seeing it turn yellow. What else are you noticing?
It's changing color, and also there's steaming.
Changing color, that's a good thing. It's steaming, you're seeing something get released. Why don't you feel beneath it? Notice anything?
I feel like a little bit of stuff.
Okay, try to put like your forearm under there where you don't have the glove. You notice anything?
Oh no.
No? Okay, let me see. Ooh, we're gonna mix it up a little bit more for you. How about now? Let's see, I'm just gonna put it where you can feel it.
Oh yeah.
What do you feel?
I feel like little bumps.
Okay, feel little bumps. Do you feel anything with the temperature?
Oh yeah, definitely.
What do you feel with the temperature?
It's more hotter.
Okay, so we're gonna go over to our model here. So when we dumped it, it went from red, what would you say it turned to?
It turned first to yellow.
Okay.
No, first to orange, then yellow.
Okay, so we finished at yellow, so it changed colors. That's a good clue. What else did you say happened?
It's starting to steam.
Okay, so we had some gas release. All right, and then how about that temperature? What'd you say about the temperature?
It's way more hotter.
Okay, so it got hotter. Now, all of those things are very important. We're gonna put that for our heat, okay?
Okay.
Now, what we're gonna do is we're gonna make sure, we want to do this again. Maybe it was just a freak accident. Maybe I told you the wrong thing. So you need to say, hey, I need to make sure I'm giving you the right directions, okay?
Okay.
So now what we're going to do is the same experiment. This time you're just gonna put a half teaspoon of the calcium chloride.
Okay.
So go ahead and put a half teaspoon of the calcium chloride in there.
You throw it in.
Okay, it's in there. Prep. Now what do you think we're gonna do with the red phenol?
Probably mix it with this red.
That's a red phenol, and we have 5 milliliters. We're gonna repeat our experiment. So what did you do last time with the red phenol?
I put it in the cup gently and just closed it.
Perfect. Why don't you do that same thing for us? And we're gonna see what happens. What did we leave out this time? Did you know something?
The chlorine.
The sodium bicarbonate, exactly. We're gonna see what happens just with this. Now, mix it up, shake it. There you go. There you go.
Oh, it did change a lot.
Okay, so what are you noticing here?
It turned pink
Okay, different color.
and it's way hotter.
It's a lot hotter. Okay, so we left out this. Let's go back to our model. And this time it turned what color?
Pink.
I don't have a pink. Let's do a, here. How about a red and an orange? Would that work? Let's use that as our pink. Let's see, that's a sign. Oh, look at that. We're getting a little pink. Who knew we were going to do some art too? And how about the heat? What happened to the heat?
Oh, it was way hotter.
All right, bigger, hotter, just like that. Perfect, lot hotter. Okay, we need to do this one more time. Are you ready?
Yes.
Okay, let's do this one more time. This time we're going to do a half teaspoon of the sodium bicarbonate.
Okay. Okay, you gotta take it. And then right here.
Okay, perfect. I like your scoops. You don't go cheap on those scoops. Those are perfect. And put that right back in there.
Okay, open it.
The red phenol.
Put it in. And
close.
it gently.
Okay, now go ahead and what are we gonna do?
Shake it.
Exactly right, and you're gonna explain what are you seeing?
Okay. Oh, that's a cool change.
So what are you seeing with the color?
It stayed the same, but a little bit more red.
Okay, so it didn't change as much color. How about the heat? Did you notice as much?
It's cooler.
Okay, it's cooler, not as much heat. What did we leave out of this one this time?
The pebbles.
Okay, the calcium chloride. So now, what color do you see it? It's more of the what?
More red.
Okay, more of just the red, almost close to what it was here. And the heat, what did you say about the heat?
It was way more cooler.
Okay, it was a lot cooler. So this time we'll put some this to show the coolness. Okay. So, do you want to know what these are now? Are you getting excited?
Yes.
Okay, here's what these are. The phenol red. The reason we have phenol red is we use that to see what's acidic or what's less acidic.
Oh.
Okay, so when you bite into a lemon, what type of face do you make when you bite into a lemon?
It's kind of sour.
Yeah, okay, sour, really acidic. You feel that acidic? That is going to turn more of the yellow. It's going to go towards more that way. Okay?
Oh.
When it's red or moving more towards the purple, it's less acidic.
Oh.
Okay? So that just lets us know how acidic everything is. Is this a different color than these two?
Yes.
Yeah, why do you think?
Because of the chemicals.
Okay, the chemicals. And did we use the same chemical combination each time?
No, we didn't use this. You didn't do both at the same time.
No, so it did. It changed it. Okay? Then the calcium carbonate. This is going to be interesting. What that does, it's perfect. You all just talked about snow, correct?
Yes.
Guess what happens? I live in Tehachapi, and guess what happens after snow and it melts and it gets real cold at night? What do you think happens to the water?
It turns into a little solid piece.
Yeah, it turns into a solid ice piece, and you will slip on it when you go outside. I've done it before. So this is what they use for de-icer.
Oh.
And it helps because what did it create? A lot of what?
Heat.
It created a lot of heat. And finally, sodium bicarbonate. Have you ever baked cookies or pancakes or anything?
Yes, sometimes I help.
Okay, sometimes you help. Have you ever had to use baking soda?
Oh, yes.
That's all you've done. That's a fancy name for it. So next time you're in the kitchen, say, hand me the sodium bicarbonate, please. And then you can be the smart one in the kitchen, right? Go ahead and practice it. Go ahead and say it. Hand me the sodium bicarbonate.
Carbonate.
Don't say the calcium chloride. Those aren't going to make good pancakes, okay? Sodium bicarbonate. All right, we have one more thing I need you to help me with. Now that you have all this science, and I think you have the idea. I have 3 boys at home, okay? They like playing pranks on me.
Yeah.
So what they did for me today is, talking about ice, they put my house key in ice and they froze it.
Oh no.
I can't get in. And it's gonna be like 28 degrees outside. I don't wanna sleep outside. Can you help me get this out of the ice?
Yes.
Okay, now I need this to melt very quickly. So what do I need? How do I get things to melt? What do I need to create in temperature?
This one. You need to do this with the red.
Okay, you saying I need the calcium
Yes.
bicarbonate?
Yes.
Okay, why? What's it gonna do?
Because this one is for the snow to melt it down, and this is gonna help it mix it around.
Okay, in the science world, let's give it a go. That's what they call it. They just say, let's give it a go. That's how we got to the moon. Let's give it a go. So here's what I need you to do. You're gonna pour, oh, perfect. Actually, you do that. Put a heaping teaspoon, a half teaspoon in there this time. And actually you had less this time when I said heaping, so. It's all right, that'll work. Put in one more. Come on, this is the final. You're helping me out. I wanna get in the house very quickly.
That's not a lot.
Oh, here you go.
A little bit more.
Perfect. Now, go ahead and pour a little bit of this in here. Just a little bit, about half. I'll hold it open for you.
Oh, God.
Yeah, go ahead. No, pour a little bit more. You're fine. You can go in there. We're gonna mix it up. Okay, perfect. Now go ahead and seal it.
Seal it, and then mix
And then mix it all around.
it.
What are you feeling? Are you feeling?
No, it's cool because of the ice.
Right, the ice. But that's okay because we know from our previous experiment what's happening. And I see it
It's-
moving around. Is it coming out?
Yes, it came out.
I think we're gonna be able to get home. I appreciate that. Oh, they didn't get me this time with help of my friend Angel here. So that's our science today. Chemical reactions. What do we learn? Chemical reactions, we want to see a change possibly in
Yeah.
temperature,
Yeah.
possibly in color, and then releasing of something. Did we see all three of those today?
Yes.
Did we have a chemical reaction?
Yes.
How's my key looking?
More just like out, more out. Because right here was more inside the ice.
Okay, hopefully by the end of the episode I'll be able to get home. Thank you, Angel.
You're welcome.
Thanks for that, Justin. Now, I know you're pretty new with Science for Kern since the beginning of the year, but if somebody wanted to find out more about Science for Kern, where would they need to go?
Probably the easiest place is going to the KCSOS website, Kern County Superintendent of Schools, and you'll see it there in Science for Kern. Plenty of NGSS aligned curriculum, resources for teachers and classrooms alike. That way we have my friend like Angel in here who can solve those problems all throughout the county.
All right, nicely done. Thanks for that. We'll be back with more right after this.
My name is Nate Ermston. I'm the dean here at CTEC. Usually the dean has a lot to do with discipline, but our students here at CTEC are actually very, very good, and I rarely have any discipline issues. So I also get to work with our ASB students, which we call our ambassadors. So our ambassadors is a group, one student from every program. They are great students. They're students who know that they're going to be out of class, and so they can always get caught up with their stuff that they're doing. And what we do is we build leadership characteristics. We put our ambassadors really out in the front of our campus. They represent our student body in many different things. When we have visitors come, they're there to greet the visitors, take them on tours, do all kinds of different stuff. And so this group really is about building leadership abilities and leadership skills, and to be able to make that next step in their life. Really to build some confidence in being out in front of people, speaking in front of people, and really just understanding what it takes to represent our student body here at CTEC.
Hello, my name is William. I am the president of the ambassadors here at CTEC. I am in the nursing assistant program. And to be an ambassador is to really show leadership on the campus. Everybody in each program has one ambassador, and we all come together twice a month to really decide what we're going to do for our community here at CTEC, but out in Bakersfield as also.
An ambassador is the equivalent of the student body at your home school, seeing as we're in a career technical facility. We needed some form of student leadership, seeing as how jobs themselves, as you go higher up in the tiers of skills, you place more into leadership there. So we decided to create a group that's the equivalent of the student body. Plan events, we conduct leadership conferences, we go out and get training for that. We practice soft skills often, we learn to communicate with each other, and we try to monitor the student body around, give help when we can. It's a lot easier to talk to people. Talking to people, especially in jobs, as you go through the ranks, you need to talk to people, you need to be able to communicate openly. There's a lot of things you can do with meeting leadership that you can apply later with your own job.
And once again, those are all self-produced entirely by the staff and students over at CTEC right there. So we do appreciate them sending them to us here on Do the Math. And speaking of student ambassadors, they were talking about ambassadors for CTEC. You are now going to be an ambassador for Do the Math.
Okay.
Did you know that?
No.
Well, I'm glad you said okay, though, and I'll tell you a little bit more about that in a little bit. But you still need some more help with your mixed numbers and fractions, correct?
Yeah.
All right, over to the board, because here's one that you said you needed a little bit of help with because you didn't see all of the numbers there. So we have 7 minus 9/10.
Okay, so what is so different about this one compared to what we have been doing already?
This one doesn't, the whole number does not have a fraction.
Oh, so the whole number doesn't have a fraction. Can I step back to the very first problem?
Yeah.
Let's go back to the first problem, okay?
Yes.
And that one, I believe the answer was
1/28.
1/28. But before, to get that, we had what's called an improper fraction, right?
Yeah.
And it was 29 over
28.
And then do you remember how I decomposed this, how I broke this out?
Yeah.
How did I break this apart?
You need to take out you need to send 29 minus 1,
Okay.
and that would make a whole with the 28.
And how did I write that one whole? I wrote it as?
1. No,
I had 28 as the denominator, but what did I have as a numerator to show my one whole? Well, we have our 1 and 28. That's not one whole, right? This is one piece out of 28. But how do I show one complete? What's going to be my numerator?
When you do the other numbers.
Okay. If I have 28 out of 28 pieces, does that make one complete piece?
Yes.
It does. That makes one whole, right?
Yes.
So we broke this apart. We decomposed this as 28 over 28 plus 1 over 28, correct?
Yeah.
Okay. So we're going to use this knowledge for a second because we know that that just equals 1, right?
Yeah.
Using that knowledge for a second, we're going to come over here to this 7 because you took this one whole and then you added it to get the 8.
Yeah.
Okay? We're going to decompose this 7. Okay?
To 6.
To 6, yes. We're going to decompose this into, let's do it right here. 6 plus 1. The 6 plus 1 equals 7.
Yeah.
Okay. So this one whole piece, we need to break into a fraction.
Oh.
What kind of fraction? Thinking about how I broke this to 28 over 28, looking at your problem, what fraction can I break this into?
Like a 10 over 10?
Yes! So now we're going to rewrite this, okay? Let me go ahead and erase this. So we're going to rewrite this as 6, and what did you just say?
10 over 10.
10 over 10 minus
9 over 10.
Because this says the exact same thing as this. Now can you solve that?
Yes, because these two are the same. And 9 minus 7 equals, 9 minus 10 equals 1.
Okay.
And then the numerator, the bottom number, always stays the same. And if there's no whole number right here, you bring down the whole number.
There you go. Now, let's think of this on a number line as well, okay? Have you been using number lines at all?
Yeah, when I play the math game Prodigy.
Oh, okay. So if we have a number line and visually looking at this, okay, if I have, I'm gonna do 5, let's see, that's a lot of 10s. Let's have 5 there. There's 6. And 7. So if we're at 7 and we're taking away 9/10, right?
Yeah.
That's what this is saying. I have 7 and I'm taking away 9/10. Can I borrow your pencil? So we need to go back 9, don't we?
Yeah.
So count with me.
1, 2, 3, 4, 5, 6, 7, 8, 9.
What am I left with here?
6,
And
1,
out of,
7.
well, 10, right? Did we make 10 marks across?
No, we made.
Well, we made 10 little tally marks, right? I
Yeah.
made 10 little tally marks. So here, let's see if we can, we have 6 and 1/10,
Oh, no.
which is 6 and 1/10.
1/10.
So you could even use a number line. And again, I broke it into whatever my denominator is. So I broke my sections into what that denominator is. So we can also look at it like on a number line.
Oh, I never knew that.
So which way, looking at these, you have 2 different ways to solve this now, huh?
Yes.
One, you could decompose your number,
Yeah.
or we can kind of make a number line to visually see that.
Yeah.
Okay?
Well, let's try it again then.
Okay,
All
you
right,
ready?
so here we go,
You
another
ready
one of
for
your
me to
homework
erase that?
problems.
Yes.
You got it? Okay.
So we have 4
Yep, there you go. There's yours.
minus
I feel.
5/6.
Minus. So whichever way you are most comfortable with, Angel, go ahead and solve that.
Okay, so now that you decompose this number to a 3, and you see, if you see this, you have to put 6 over 6, and it is equal to that one. So we have to erase the 4 to make it a 3, and a 6, and put the fraction, and then you have to do the subtraction. 6 and 6 is obviously the same thing. And then 5 minus 6 equals 1. And 3, there's nothing on the bottom, you just put it down.
There you go.
Nicely done.
Nicely
So
done.
you've got those whole numbers out of the way now.
Yeah.
We're going to go to the very last problem on your homework because usually they get a little more difficult as we go.
Yeah.
So let's take a look at the very last one you have on your homework. 9 and 1/9 minus 1 and 4/5.
4/5?
4 over 5.
Okay, Angel.
Okay, the really is these two are not the same, but I realized they're both odd numbers, but
Okay.
none of them could multiply into each other.
No, but can we multiply them together?
Yes.
Okay,
To 45.
okay.
That means right here would be 9 and 9 times. So 4 times 9 equals 36. And then here would be 5 times 9, which is 45. And then up here would be 1. No, wait, no. It would be 5. Up here, 5 up top and the bottom. 1 times 5 is 5. And 9 times 5 equals 45.
So here we have a little bit different situation happening.
Yeah.
What's different about this problem?
The smaller numbers on the top.
Right, the smaller numbers on the top. So we need to make this a larger number, don't we?
Yeah.
Yeah, so guess what we're going to need to do?
Take one out the whole number?
Yes. So do we need to decompose this?
Yes.
Yes.
Into an 8.
To an 8. So we're going to change our 9 to an 8.
To an 8, and then
We need to add
a whole.
a whole. And what is that whole going to look like? What kind of fraction?
45 over 45.
Let's add that to that. What is 45? Well, keep our 5 here for a second. We need to add 45 over 45.
That'll be 50.
That's going to be 50.
Oh, okay, then.
Right? So now, can we rewrite this?
Yeah.
50 over
50 over 45.
And let's bring this over here too.
And over here, you put 36 over 45.
Now, are you ready to subtract?
Yes.
Okay.
6 minus 0, you can't do that, so you have to regroup and make this one a 4 and a 10. 10 minus 6 equals 4. You always put the numerator on the bottom. And then 3 minus 4 is 1. It will be 14 over 45.
Okay, well, what about our whole numbers?
And then you minus them, so that would be a 7.
Over
14 over 45.
14 over 45. All right, there you go. So we did a lot of decomposing today, didn't we?
Yes.
And that, again, are you real comfortable with that decomposing?
Yes.
Okay. Good job. Good job.
All right, come on back over here. So, the last one you just did was 7 and 14 over 45. So why don't you go ahead and put that one down there.
Okay.
We're going to make sure we get these filled in on your homework so that you at least have these ones done for your homework.
And
Right?
then
This one up here, that was your 6 and 1/10.
6 and 1/10.
And if your teacher goes, hey, I don't see any work being done with these, you go, well, just check out the YouTube, do the math. You'll see me doing them, right?
Yes.
And then you have 3 and 1/6.
3 and 1/6.
Now, earlier we were talking about how the CTEC students had student ambassadors, right? And I said you were going to be an ambassador for Do the Math, correct?
Yes.
Do you know what that means?
No.
All right. Well, the first thing it means is that you're going to get a uniform. So turn this way. And this is your new uniform.
Oh,
What do you think of that?
it's cool.
It is
I
cool
like it.
indeed, it is right
I
there.
actually like it.
So what's going to happen is you're going to wear this, and you're wearing it at school, let's say, and maybe your principal or teacher or some other kids go, hey, what's going on? What's this shirt all about? So what can you tell them about Do the Math?
I'll tell them that it is something that could really help you learn more about math and help you do your homework.
There you go. So we'll help you with math, we'll help you do your homework, and you even had an extra activity with Science for Kern, so
yeah.
you especially like doing that, right?
Yes.
What did you like most about the science activity?
That I figured out what some chemicals do to other chemicals.
And do you remember the stuff that you might have to help you bake?
Yes.
What is that? Do you remember?
The baking powder.
Right. And do you remember what the chemical name was?
I forgot the name.
Right. Bicarbonate it was in there, remember?
Bicarbonated.
So, you know what? You're going to get that later on, and you're going to be able to take the poster home so that you can remember all the activities that you did with that today, right?
Yes.
Okay. So do you think you have a little better handle on the fractions and what you were doing with those?
Yes.
All right. And what about the ones with the numbers where you're like, at first you were like, well, there's no numbers there.
Yeah, I was confused at the beginning, but I figured out those were holes.
Right. So you know what to do when you have a whole number now, and you need to make it into a mixed
Fraction.
number, right? So you have a fraction next to it.
Yeah.
All right. So is this going to be your last year at Fairview?
Yes.
Do you know where you'll be going to school next year?
I think McKee.
Okay. Is there anything you're looking forward to when you go to junior high school?
Probably like art class and like probably more math.
So more math. And did you say art class?
Yeah.
So you like doing art?
Yeah.
Is there something you like to do more than others? Do you like to paint, draw?
I just draw some characters that I made up.
All right, well, good. Well, you know what? Being creative like that is always helpful. And the more math you do will also be helpful, all right?
Yeah.
Did you have fun?
Yes. A lot of fun.
Well, good. That's what we want to know. All right, you know what? We do have phone tutors available Tuesdays and Wednesdays between the hours of 3:30 and 5:30. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.